Hi everyone, today we will try to do integration by parts. So I learned topic, now I want to practice from my university's book. So our topic is integration by parts. If I have any difficulty, I will ask to my teacher or just AI. So let's start by problem 1. Okay. Our problem 1 says that determine x cosine x dx. Now I will write like this. That is our u dv, okay, dv, du, dv. So if I had to choose, we had a tip, by the way, how can we find u? So for this, we have Lipid technique. So to choose u, we will use Lipid technique. And L, logarithms, inverse, polynomials, exponential, and trigonometrics. Okay, trigonometrics, but in this situation, I think that if we say that our u is x and du over dx will be 1 and du will be dx, that will be more easy to find. So our u is x, du is dx, okay? Then our cosine x will be dv cosine x, and the integral of cosine x will be cosine. Integral of cosine is always positive, so it will be sine x plus c1. But okay, we can write c1, but I think it will be better to write in the end. So our formula is u dv equals to uv minus the integral of v du. Okay, u dv is this one. So and math professor we says that firstly do this and then do this. So firstly we need to do this one, uv will be x sine x minus the integral of, from that formula, by the way, this one, yellow one, sine x dx. So x sine x minus the integral of sine is cosine but negative cosine, x plus c, x sine x plus cosine x plus c. I think it's true. Hopefully it's true. Let me see. X sine x plus cosine x plus c. So yeah, this one is correct. Let's do the second one. Oh my gosh. I want to write with not t but just x, because this topic is so new for me and I don't want to confuse myself. So actually it doesn't matter, but I will do like this. 3x times e to the power of 2x dx. It is the same thing, but as I said, I don't want to confuse myself. So we write u dv, and so what is our u and dv? Basically, because this one cannot change, as you know, that the integral and derivative of that one, e to the power of x, is just giving us itself. So I want to take this dv as e to the power of 2x, and the integral of e to the power of 2x will be e to the power of 2x over 2. In this case, our u will be 3x, and du over dx will be 3 and du will be 3dx. Okay, du is 3dx. All right, and this one, then this one. Let's do this. 3x e to the power of 2x over 2 minus integral of e to the power of 2x over 2 3dx. Okay, no, just let me write this. 3 over 3x over 2 times e to the power of 2x minus just simply 3 over 2 e to the power of 2x over 2 plus c. 3x or 3 over 2 times e to the power of 2x times x minus 3 e to the power of 2x over 4 plus c. I think it's correct. Let me see. Yeah, that's true. Okay, good job. I don't know this ones, so let's go to the another one. I also don't know this one because it has borders and I don't know how to do with that borders. Okay, let's do this one. X squared sine x dx. X squared times sine x dx. We said that according to our Lipet technique, u will be sine x, trigonometric ones. But I don't know, let's just check it, because in the first example that wasn't like this. But let me just check it, okay? If we say that, okay, u, that will be du, and it will be just v, okay? Trigonometric, okay, according to Lipet, u is trigonometric. Okay, let's say sine x, and derivative of sine is what? Derivative of sine. Oh my gosh, I really struggle with that. Okay, sine will be cosine x, but positive or negative? Let me think about it. Okay, the integral of cosine is negative. It means that the derivative of cosine is positive. If cosine is positive, sine will be negative, so it will be negative cosine, or no, sorry. So integral of cosine is always positive. Integral, it means that derivative of cosine is negative. If the derivative of cosine is negative, it means that this one is positive. All right, cosine x, and let's say it is our du. That will be what? X squared, it will be x cubic over 3 uv, basically this one, and then this 2. Okay, I just again I want to write our formula. I think that it's not a good technique to use this one because it simply is not good technique for us. Why this is not an easy technique? Because it could be better if we use u as x squared, because the derivative of x squared will be 2x, and that will be really easy for us to solve that problem. However, I just wanted to try that Lipet technique, and let me see that where will we end up. Okay, so our formula is u dv equals to uv minus v du. Okay, sine x times x cubic over 3 minus integral of x cubic over 3 cosine x. So it will be really hard for us, but I want to try with another as I said, like I want to make u x squared, so I will try with that technique as well. Okay, sine x times x cubic over 3 minus 1 over 3, okay, x to the power of, just let me write this like this, 1 over 3 times x to the power of 3 over x to the power of 4 over 4 times cosine will be always positive integral of cosine, I mean plus c. So sine x times x cubic over 3 minus sine, no, just like this, sine x times x to the power of 4 plus c. I don't know if it's true or not, but let me check it. Okay, it is, yeah, it's not like this. Okay, all right, let me try with other one. So we basically say that I just want to rewrite it, x squared sine x dx, and that is our u, and this one dv, that will be du, that will be v. U is x squared, 2x sine x, integral of sine will be what? Integral of sine x, and integral of sine, v. X will be negative cosine x, because the integral of cosine x is always positive sine x, and integral of sine x will be the reverse one. And that is our v. Okay, let's do x squared negative x squared cosine x minus integral of x squared negative cosine. Okay, no, just do this like this, cos x 2x. Okay, negative x squared cosine x plus cosine will be what? It will be like 1 over 2, cosine will be sine 2x plus c. I think it's like this. Let me check. Oh my gosh, what is this? No, sorry, my bad. I made a mistake. I didn't understand this one, by the way. I just saw my mistake. That 2x is what? Integral of 2x will be 2x squared over 2, basically x squared. So we also need to use again this one. Yeah, we need to use again, I guess. Wait a second. Let's say that if we use this one again, u dv duv, u cosine 2x, it will be 2, dv will be cos x, integral is integral of cosine x, it will be sine x. Okay, and this will be uv sine x 2x times sine x minus integral of 2 cosine x, 2 cos x, and it will be 2x sine x. Integral of cosine x will be 2 times sine x. Okay, 2x sine x, and this is the 2x sine 2 times 4x sine square x. I don't know where that going on. just want to try this one. So wait a second. I will ask this one to my teacher. I think that we need to use this again. Okay, let me see. What is this? I think that we need to do this one. With that, I think it's correct, but let me ask this to my teacher again. Negative cosine x to x, okay. And again, you use u, yes, u dv and duv. U to x, derivative of, okay, du over dx to x, it means the derivative of du over derivative of this one. U is this one, okay, derivative of this one is with this one, du will be 2 dx, okay. So that's my bad. Okay, let's say that's u, that is dv, du, v. Okay, if it is 2x, u is 2x, du over dx will be 2, and du will be what? 2 dx, okay? Du will be 2 dx. What about the cosine? dv is cosine x. Integral of v is what? Integral of cosine x. And v is what? Cosine integral is sine x. Integral of cosine is always positive and sine. So du is cosine x, that will be sine x. And if we use this one, that will be like 2x sine x minus integral of 2 dx, no, sine x 2 sine x dx, okay, times dx, no, not times, sorry, dx, all right, 2x sine x minus 2, integral of sine is cosine, but negative cosine x plus c 1, but not need, 2x sine x plus 2 cosine x, okay, 2 cosine x, and just write this to here. Two x sine x plus 2 cosine x. But I want to organize this one. Okay. Negative x squared cos x plus 2x sine x plus 2 cos x plus c. Okay. Okay, then we have cosine x 2 minus x squared cos x 2x sine x plus c. Good job, very good job. I did it right. All right, this simplified form, actually. All right. Now we will do further exercises, but I don't want to do them anyway. I don't want to do them. I just want to do those problems, all of them, okay? Let me just do the problem 6, okay? Find x ln x dx, okay? X times ln x dx. According to our rule, ln x is always u, okay? So we will write like u dv du v, okay? V u dv, okay, our u is ln x, the derivative of ln x is 1 over x, that is x, that will be x squared over 2 plus c1, but we don't need to write this one, so it will be this one, ln x times x squared over 2 minus integral of, according to our formula, by the way, x squared over 2 times 1 over x, then it will be ln x times x squared over 2 minus x over 2. By the way, let's write this like 1 over 2 times just integral of x, okay? And it will be ln x times x squared over 2 minus 1 over 2 times x squared over 2. It will be ln x times x squared over 2 minus x squared over 4 plus c. I just didn't simplify it, but I'm sure that it's correct. X squared over 2, okay? ln x, that's correct. 1 over 2, that's exactly like this. But I'm really not good at simplifying. So that's why, anyways. So let's do problem 7. The integral of ln x dx. It will be like what? Let me see. We know that integral of ln. So why should I do something like this? U and dv. ln is always... Okay, we need to do this with that formula. Okay, ln is always what? We need generally u and dv, okay? dv. Our u is ln x, and du will be 1 over x dx. 1 over x dx. Okay? And our dv will be 1, it's just 1, and integral of 1 is x. Maybe this is what they mean. Integral of 1 is just x, okay? I just guessed this like this. So v is x simply. And then what? Just according to our formula, this one, uv ln x minus integral of this one, 1 over x times x dx, okay? And it will be like ln x times x minus, they will cancel each other, integral of 1, okay? And integral of 1 is what? Just nothing, okay? That's also a big mistake for me, that I made this mistake, by the way. It's just ln xx, isn't it? Plus c. Or what? What is this? Okay, let's say that that's x, okay? Let's say that's x. Okay, I think, by the way, it's a mistake. But it's just 1, okay? ln x times x minus x plus c is what I think and what I mean by writing this one. I didn't get anything, but okay, it says that we have x, so that's why ln x minus 1, yeah, because we have common factor x. ln x minus, by the way, that was right, what I was thinking was right. So good job, really good job. I don't know exercise with that borders, so I will skip them for now. What is this? E to the power of ax cos bx. So that is a little bit hard for me with a and b like this. E to the power of ax times cos bx times cos bx dx. So u dv du v. I like writing this. I think that e to the power of ax will be v because it never changed. Okay. So e to the power of ax over a cosine bx will be cos bx will be what? We don't know what is b. B can be 1 or not. Not if that was 1, we could, okay, that's something like, okay. Cosine is, integral of cosine is always positive, but derivative will be negative. So that will be negative 1 over b sine bx. Okay, and let's try to find that. That's like, they will be together according to our formula. E to the power of ax over a times cos bx minus integral of e to the power of ax over a times, just there is a negative and I don't want to write this negative, so that's why it will be positive, 1 over b sine bx, 1 over b. Let's write this like this, a times b times sine bx. Okay, e to the power of ax over a times cos bx plus e to the power of, okay, we need to find the integral of this one as well, but I need to again write that u dv for this one, u dv. Okay, our u will be what? I think that dv, u is sine bx, du will be what? U is sine bx. Du over dx is, the derivative of sine b is 1 over b times integral of sine is negative, but derivative is positive cosine bx. Is that true? Okay, let me think again. Integral of the positive, sine will be negative. If the integral sine is negative, derivative is positive. Okay, that's true. Okay, du is what? Cos bx like this. Cos bx like this. Du is what? Cos bx. Cos bx. No, wait a second. That will be cos bx dx over b. Over b. Okay, what about, so cos bx b, cos bx over b dx. All right, what about the other one? dv, e to the power dv, e to the power of ax over ab. V is integral of e to the power of ax over ab, and I could prefer writing this like v is 1 over ab times integral of e to the power of ax, and the v will be what? 1 over ab will remain like this, e to the power of ax over just a, and our v will be e to the power of ax over a squared b. Okay, like this. Okay, like this. And let's find, like, firstly sine b, e to the power of e to the power of ax over a squared b times sine bx minus integral of e to the power of ax over ab times cos bx over b dx. Don't worry about that dx, okay? E to the power of ax over a squared b times sine bx. I think that I write something wrong, but anyways, ab times e to the power of ax again over a, and it will be e to the power of ax e to the power of ax over a squared b, a squared b, a square b. Okay, a squared b times cosine will be what? 1 over b. That is times, by the way. That must be in brackets. Not in brackets, but 1 over b times. Oh my gosh. That must be like just 1 over b, okay? 1 over b. And cosine bx will be what? Cosine integral is sine 1 over b sine x. And just substitute this one. And this one like this, e to the power of ax over a times cos bx plus this one is what? We are just calculating this one. E to the power of ax over a squared b times sine bx minus e to the power of ax times sine bx, not sine x, sine bx, sine bx, a square b cubic. I'm pretty sure that it's not correct. Oh my gosh, okay. And this one plus this one I'm not sure. Fuck off, what is this? Okay, let me see. Okay, I think it's correct. I don't know that exactly, but